If you go on our channel and look at the space videos we upload, we have plenty of them in there. So in this video, we're back again talking about space. If you've seen space videos, you know that the weird stuff and interesting things are pretty much endless. Any corner of the universe you look at, there's something interesting to see or talk about. Some of them are extremely interesting, some of them are very weird, and some of them are extremely terrifying. Like for example, the neutron star, or even scarier than that, magnetars. Before we start talking about magnetars, let's look at neutron star first and then we'll move on. Neutron stars are very similar to magnetars. What you're seeing is a neutron star. In simple terms, the way a neutron star gets formed is that a red supergiant, basically a ginormous star, gets to the end of its life and it finally explodes in a supernova. When a star explodes through a supernova, it pretty much scatters all its guts through the universe, and the gas and debris leaves a nebula. But now, the core of the star that used to be there has now turned into a neutron star. Not every time a neutron star is formed by this. It only happens when there's so much temperature and pressure that it causes the electrons and the protons to fuse together and turn into neutrons. That's why these stars are considered neutron stars. These stars aren't ginormous whatsoever. They're only 20 kilometers across. But the insane part is that even though it's only 20 kilometers wide, its mass is greater than our sun. Just imagine the density of it. If you've never seen this is called a thimble. Sewers put this on their finger so the needle doesn't go through their finger and it doesn't help them when they're working with it long term. But if you take this thimble, which is extremely tiny, and put neutron star material inside it, can you guess how much it will weigh? You're not gonna believe it. It will weigh 100 million tons. 100 million tons is 15 Great Pyramids of Giza. Just thinking about the sheer weight of this thing is ridiculous. And another interesting thing is, neutron stars spin around themselves so fast that they have the fastest rotation in the universe. At least the fastest we know of. This is the fastest neutron star in the universe that has been discovered. PSR J1748-2446 AD. This neutron star spins around itself at 24% the speed of light. If you want to understand this speed a little bit better, it rotates around itself 716 times a second. This was a terrifying star, right? But you have to know there's much more terrifying than this. Magnetars. Another way you can calculate the gravity of this star, if you were to stand on top of it, you would weigh 2 trillion times the weight you weigh right now. But the funny thing is, the magnetar is 1,000 times the neutron star. Physicists and astronomers believe that magnetars have the strongest magnetic fields, and that's why it has the name magnetar, which comes from the word magnet. Magnetars are the only stars that an earthquake, or should I say magnetar quakes, could happen. It's not like the earthquakes we're familiar with, where tectonic plates causes it. In some of these starquakes, the crust of the magnetar could crack, and a huge burst of energy could exit the star all of a sudden. But it's not like it's a laser shot, it's actually radiation. Radiations that are so powerful that you could detect it millions of light years away. In the year 2004, one of these giant beams reaches planet Earth. But thankfully, the radiation came from 50,000 light years away from us. A beam that came from this magnetar SGR 1806-20. When this burst reached planet Earth, it changed science forever, and physicists got to know what these magnetars are actually capable of. They realized that these magnetars will release so much energy in 1/10 of a second that it could be comparable to the sun's entire life. It's basically releasing more energy in 1/10 of a second than our sun does in its entire life. Thankfully, these radiation waves were extremely far from us, so they didn't have a negative impact on our planet. But physicists believe if a magnetar is about 10 light years away from us and something like this is shot towards our direction, it's gonna be a huge problem. Because first of all, we don't know it's coming. And second of all, if it hits us, it first destroys our atmosphere completely and turns the entire planet into a hell. That basically means planet Earth will no longer be able to sustain life. The worst part is that you can never predict when a star quake is gonna happen on a magnetar. The only way you could realize this has happened is that if it already hits you, and that means it's too late. But the good news is that scientists believe that there is no magnetars nearby. The closest magnetar is XTE J1810-197, and it's 8,000 light years away from us. And that's a fairly safe distance. So when a star quake happens on a magnetar, what type of radiation is released? Gamma rays. Gamma rays are the strongest and the tiniest waves. And in simple terms, they'll pass through anything and destroy you. Gamma rays are very similar to radioactive radiation. In chemotherapy, gamma rays are strategically used to kill cancer cells. Even though they kill cancer cells, they also kill a lot of healthy cells, which is why a person that goes through chemo lacks a lot of energy, and they also lose their hair. But chemotherapy is only a little bit, and it's in a specific area. But gamma rays could be very much seen in the Chernobyl explosion in the Soviet Union, or the atomic bombs in Hiroshima and Nagasaki. But these radiations on Earth are nothing compared to the radiation that comes out of a magnetar. Neutron stars on magnetars use so much of their energy per second that they have a very short life. At least a short life compared to other stars, because they die very young. They go so full throttle that they will run out of energy in 5 million years. But what happens when they die? They turn into white dwarfs. So what is the point of magnetars and why should we study it? Things like this are extremely interesting for physicists and astronomers because they could learn from it. Maybe they could figure something out and they could invent it on planet Earth right here, because something that creates and releases this much energy could be useful even if we could imitate it just a little bit and use that unlimited energy here. But you also have to be extremely careful, because if you mess around with it too much, you might make something that ends the world.